bensound.com. 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 bensound.com.
Well, hey everybody, welcome to exam prep night here Wednesday night. Sorry we missed last Wednesday night, but had prior commitments. So we're going to do it this Wednesday night. So thanks all of you that are in your studying for your exam. Last week or two, we've got quite a few students who've actually taken their exam and passed their exam. So that's awesome. Shout out to all of those that have taken their exam and passed it. Absolutely. It's always a wonderful thing. For those out there who are trying real hard and didn't succeed on the first shot, don't fret. Don't get discouraged. You'll get it. Just keep plugging along at it. Again, if it was easy, everybody could do it, right? So again, takes a little bit of time sometimes. Sometimes you get it right away. So what you probably heard this week before we get into a lot, what you probably heard this week was I did a podcast on a fast track students' dedication, and this can apply to anybody, not just fast tracks, by the way, is dedication to it and really studying and being devoted to it. You can't just pop in and out of something and expect to have any success with it. You have to stick into it. Okay, you have to stay into the study. And if you are finished studying, or you think you're finished studying, and your exam is not for 3 weeks away or 4 weeks away, then you're not done. Okay, you want to study all the way up until you take your exam. You want to try to take. I tell students in the fast tracks, if you finish the program, you want to try to take your exam. You want to try to take it within 7 to 10 days of finishing your program. But again, exams throughout the country are different. Ones are tougher than others. Basic knowledge is there. You just sometimes it's harder, and it might take multiple attempts. So just keep plugging along at it. Definitely don't want to get discouraged. Again, we've all been there. My hat looks terrible tonight. I'll never get hats from this company again. Every hat seems to end up crooked on my head. I might have a crooked head, but I think it's the brims. Anyway, so we're going to look at some stuff tonight. We're going to look at probably one of... What's up, James? Thank you for coming into the stream. Everybody that's out there, don't be shy. Chime in. Let us know you're here. Let me know that you're in here. Again, you don't learn anything unless we don't interact and you ask questions, and we will try to answer the questions best we can if I can answer them. If I can't answer them, I will write it down, and I will give me more time to look up the answer a little bit and be able to get it back to you. James, congratulations. I was wondering, I hadn't heard from you when I talked to you yesterday. You passed. I knew you could do it. James, you worked your way through the Fast Tracks program. Your scores are consistent. I had confidence in you. And again, congratulations again. It feels good, doesn't it? All that stress is gone, right? It's like, but remember, James, once we get that license, no matter whether it's masters, journeyman's, whatever it is, the learning just begins, right? Because there's so much more now that we're expected to know. because we're licensed, right? We're now, people refer to us electricians and things like that. So I always tell people, you're not an electrician until you're licensed. You're practicing electrical, but you're not licensed. You're not an electrician. Once you get that license, or you're an electrical contractor, then you go, you're an electrician. And so again, we're practicing the trade, and then we make it to that next level where so again, if anybody ever tells you that it's just a piece of paper, then they're a fool, because it's way more than just a piece of paper. Okay, we don't care what you know. Everybody knows how to terminate blacks and whites and reds and wire nuts and wiring up. Okay, we can do that. So I like to tell people, I can teach a monkey to turn a screwdriver. Okay, but I can't teach them to know the code, right? So again, anyway, great job. Congratulations, James. I knew you could do it. All right, so we're going to look at tonight. We're going to get, for everybody that's studying out there, those that are not in the Fast Tracks program, we're going to do a dive in for those that want to see what it looks like. We're going to do a dive in unit. You ready for this? I don't have a drum roll. I don't even have a drum roll track on my thing here tonight, but I do a fake one. We're going to do unit 8, which tends to be one of the tougher units for students. They end up doing this unit, and for some reason they have problems with it for some reason, you know? Oh, I also should tell you, we're going to use, and it pops up over this chat thing, we're going to be talking about this form tonight. This form should look very familiar for people in the Fast Track program, but you can get a form like this online. And basically what this is doing is breaking down the steps. And this is one of the forms that we use in the Fast Tracks program, because what it does is it teaches you all of the steps that are necessary. I think one of the greatest things that you can do is try to put the memory to visual, tie everything together, and it kind of becomes easier. So that's what this form is designed to do. So this form is not designed for you to use on an exam. This is not designed to do anything other than to teach you the steps. And for those in the Fast Tracks program, they should be using this form every time they do a unit that requires them to do a load calculation. And you should just print these things off. They're usually a PDF, or I think it's actually a GIF or image or PNG. Download it, save it, and then you can print it. Sometimes they don't print as well, but this one I kind of blew up. It's kind of light, but it's fine. Works fine. I can see everything on it. But again, printing off a nice one, okay? Print off a nice one, and then you can laminate it, and then you can use dry erase pens on the laminated, and you can just erase it off or whatever. Absolutely, James. Way more than a piece of paper. It's pride, man. I tell people all the time, one of the greatest things that I ever achieved was back when I got my journeyman's. And then the next year to go get my master's. And it's a lot of pride in it. You got to take pride in it. In some states, like Texas, for example, a master electrician is equivalent to the engineer. In other words, I could design a high-rise building if I want. Just some states are different. Some are limited, some are not. Texas, it's not real limited. So they put kind of a high pressure on the test in Texas. And again, it has a very low pass rate in the state of Texas. So, definitely have to, what is it, junior? You California and you failed. Don't give up, brother. 65, so close. Let that motivate you. Okay, don't let that get you down in the dumps. I know it's another test. I know it's more study time. I know it's more money. But you definitely have to really keep at it, man. It's worth it. Trust me. I'm here to help you. Email me, 10 these at night like you're doing. Do whatever I can. I can try to help you watch those videos, whatever questions you might have. If you remember some of the questions on the exam, email them to me. I'll try to help you out. Try to be as complete as you can. I want to see you succeed. Okay, I definitely want to see you succeed. So I'm here for you, Junior. I'll help you any way I can. Now, June, this isn't a calculator you see on the screen. That's a load calc form. That is in our Fast Tracks program. So I can't share that unless you're in the Fast Tracks program. Okay. But the same concepts apply, and we're going to apply it tonight as we talk about different pieces. But I just wanted to show the form, the form, if you will. All right. So, all right. And there's other forms out there. You can do it, single load, what is it? Single standard method load calculation form, one family dwelling. Probably Google it and things like that. Okay. Our tabs aren't available yet. Those that are asking, many of you probably saw that we do have a price increase that's coming November 1st. The board of directors, we met, most of y'all know, last week when they wanted me to create an affiliate program and all this kind of stuff. One of the things is there was a price increase. There was an overwhelming thought by many of the people that are in our program that says the amount of interaction that we give is our courses are way too low. And then, of course, we got hit with a bunch of LMS fees and whatnot. So we were able to hold it off until November 1st to do that. So, yeah, prices will be going up November 1st for those that are interested. So I guess it could be a sales ploy. Get in now while you can get them at the cheaper price. But anyway, I can't help it. It is what it is. It's the 2021 pricing scheme where we're changing to it. Ooh, scheme sounds bad, doesn't it? I don't know how to say it, but it is what it is. Certainly ain't gonna cost you $1,200. I promise you that. All right. So anyway, so what we're gonna do here is, Alex, those tabs are custom tabs, and I don't have. Hold on. I have people that have seen them. There's kind of a sample of them right there. Those are going to be available. Pretty straightforward and simple, not fancy, but easy to see. Are going to be available in about 2 weeks. Two different types of tabs. You got the tabs for the side, and then we'll have the other tabs that are they're called table tabs, and they're going to be all the most important tables, that type of thing. But, some people don't want tabs, and it's okay. But we will have them available, but they're very custom, okay? They're based on different code sections and tables that I wanted students to have, okay? So anyway, that's about 2 weeks for those. Let's see. Oh, and incidentally, what they look like is to show you how disgusted I am with easy tabs. See the white ones at the top? Those are our tabs. And you see the clear ones? When the light is sitting a certain way, you can't read the tab. I would hate to be in the middle of a test. And when I'm sitting here, because they're transparent, I can't hardly read them. So again, ours are not going to be the colored. We decided after my experience with these tabs, when I did that video, after my experience, I am not trusting anything that I do in my classes when we're done with this COVID thing. I'll be giving my tabs out, obviously, to my classroom classes. And I am not trusting somebody else's tabs anymore. I'm just not. So only reason we're not trying to mass produce them, we're not going to sell them on Amazon or anywhere like that, only through us. It's because I got fed up with these tabs. They were too big. They break off, and then they were transparent. I wanted something that was a little more flexible. It is smaller. So again, as a crux to us is the printing area is smaller. But I wanted something a little easier. That's the only reason we did it. Okay, we're not trying to get in the tab business. They're just there. The bigger tabs, we're determining this week whether or not they're going to go across the top or across the bottom. We're not sure yet. Many people have stated they'd rather have it across the bottom so that they can move their code book during an exam up close to the computer and they don't have the tabs to worry about pulling back. They can look down in front of them. Again, we like feedback like that, but that's still what's coming. Hey, Tim, thanks for coming. Bill, Alex, I see you in there. All right. So anyway, for those that are in the program, this right here is the tape, one of the forms that you should be intimately familiar with. I'm sure Tim is and James is, and they were in the program. Both successful, by the way, in the Fast Tracks program. I think Brian was in here earlier. He's also successful in the program. So here's the tabs. There's the form we'll be kind of talking about tonight and using a little bit. But again, we'll talk about it whether you had this or not. You'd still be able to solve it, okay? All right, let me get rid of that. All right, let's go on, guys, and go on and get into this stuff because I've talked too much as it is, as you all know. So let's go on and see if we can't jump. All right, and let's see here. Let's see here. Hold on, guys. Let me see if I can get y'all over on here. Bear with me here, guys. I'm having a little bit, I guess it didn't. All right, hold on. Let me see if I can add y'all. There we go. Bear with me, guys. Something was wrong with it, and it wasn't letting me do what I wanted to do. Okay. Good enough. All right. So for those that are in the program, it's very similar to what you see here. The only thing it doesn't have is your console on the left. You're familiar with that. You're in the program. For those that are not in the program, that's okay. This is going to be okay for you tonight too. You don't need to worry about, oh crap, I'm not in the program. I'm not going to be in. It's not going to help me. Sure it will. Don't worry. I wouldn't let you down. Okay. I'm with you. All right. So one of the more popular units that we have, and again, other nights we'll do other ones, but I want to dig into Unit 8 because we've done Unit 8 before. And in fact, in most of the programs, I give the answers to Unit 8 and how to do the calculation, at least in the 17 edition. I don't think that we're giving it to anybody in the 2020 edition of our Fast Track program because I found that to be honest with you, I wanted more students to struggle. Because it really didn't help me much when we gave you a video example of how to do the ones that we're going to talk about tonight. And then what happens is you turn it in and you get those exactly right. But then some of the other questions in the example you get wrong. And that made me realize something, that people were just watching the video and answering the questions. And that's not going to help you. Okay. So again, I have it there in the 17. I did not remove it. I didn't feel right to take it out of the 17 since it was already there. But I did not put it in the 2020 because I wanted students to really not struggle. I wanted students to have to do the work. Okay. All right. So let's kind of do that. I'm going to look at real quick. Let's get into Unit 8. So this is the reading material. And so we'll just kind of go through. I'm not going to go in how you use the reading material because that's what you read as part of your program when you're studying. Everybody in the program should be doing the reading material first, and then they do the review, and then they can do the study tools and then the assessment before they go on to the next. A little different than the 17 folks. Okay, this is a little different. This kind of looks a little different to those that aren't in the 20, that are in the 2017 versus those that are in the 2020. Few changes we made. Okay. We added that NEC drill work, which is different than the 17. So in case I just didn't want to get anybody wondering what was going on. All right. So let me see what this looks like on the screen. Make sure I'm blocking it, but I'll move me when I get to the question. First question I'm going to ask, and I'm going to ask all you students to do this, is question number 2 right here on the screen. So I want to see some answers pop up, and then I'll show you how to work this out. Okay, question number 2, it says, what is the lighting demand load before derating for a house with an outside dimensions of 30 feet by 48 feet on the first floor and 22 by 42 feet on the second floor? Okay, now the only thing I will ask is those that have done the Fast Tracks program before, hold off a little bit on your answers because you've already been through this. If you're new in the Fast Tracks program and you haven't gotten to this unit yet, that's okay. Remember, it's about learning the code. So you're going to get some answers tonight. And so I would expect some amazing grades on your competency reviews, right? Because you're going to see some answers tonight. I don't usually do this. In fact, Tim and them might tell you that it's very rare that I ever do a video showing the competency tests online. Very rarely do I ever do this. Okay, so you're in for a treat tonight to show you these. All right, so we're looking at question number 2. Now, that doesn't mean that you guys that are in the Fast Tracks don't work it out, but I want some of the students that are not in the Fast Tracks, and we've got over 20 plus people in here, and then there's some very shy people in here. But be sure to make sure that you speak up because we definitely want to hear you as we work this out. So we're looking at number 2. Okay. Where was it? Where Where was that? That's right, Brian. I didn't do these things when y'all were doing it. I didn't do any video, any of these live streams on y'all's, and I could share everybody watching y'all's scores if you want to see what y'all's first attempt was at Unit 8. Or maybe not. Maybe I won't do that. So, again, I really do try to bring you value when we do these things on Wednesday nights. So, everybody work this out. So, question number 2 is, what is the lighting demand load before derating for a house with outside dimensions of 30 by 48 feet and on the first floor and 22 by 42 feet on the second floor? Work it out, my friends. Let's see. I'm going to work it out too. I'm going to work it with you. Okay, I got my first floor. Y'all should know what to do. And if not, we're going to talk you through it. And what's the next one was? I got it written here too, because I sometimes have hard to see the screen because my console is a little smaller than what y'all might see. And, okay. Work it out, guys. This is what you need to do. You need to get used to this. This is exam type stuff. Okay. All right. Anybody got some answers up there? And we'll kind of walk you through it. I've got the code book ready. Got it all queued up. We got 22 of you, 23 of you out there watching, hopefully preparing for an exam. I don't know how many of over on YouTube, because I'm streaming to YouTube as well, but I don't know if YouTube's working. Not YouTube, but Facebook. It doesn't look like it's working over on Facebook. I don't see anybody. So, kind of work this question out and see what you get. Okay. Nobody's chiming in, so let me help y'all out a little bit. So over in, we'll use the 2020 NEC. Over in, first thing that I would notice in this question number 2 is that it's talking about before any derating. So I'm not going to worry about 220.42, the first 3,000 at 100 and whatever. Okay. All right, James, you're in the fast tracks. Actually, no, James, not table 220, but you might be in 17 code. If you're in the 17 code, yay. If you're in a 2020, no. So yes. So first thing we would do is, interesting that it's 2 floors. Okay, first floor and second floor. And, but absolutely right, James, by the way. And so if you're in the 2017 code, then it would be 220.12 is going to tell you that it's 3 VA per square foot for this house using the outside dimensions, which has been given to us. And it's 2 floors. That's right, James. I forgot. So 2 floors, right? And so we're going to do the outside dimensions. First floor, 30 by 48 is 1,440. 22 by 42 is 924. Add them together. What do you got? 7,092. This said before derating, so we didn't do anything else. Now, interesting enough on an exam, some people might say, oh, wait, Paul, wait. It wants to know the lighting demand load, and immediately they start thinking, don't I have to have 2 small appliance brand circuits, and don't I have to have a laundry? In the scheme of life, yes. In the question, no. Because it says, what is the lighting demand load before derating? Okay, so all it wants to know is the lighting demand. And based on how it's worded, then it really just want you to tell me. Now, this could have also been worded on an exam as what is the lighting connected load before derating? Okay, so it could be asking could be asked that question as well. So just be conscious of that. Be aware of it. But again, this is just simply trying to test you and make sure you know what? 3 VA per square foot. Now, in the 2020 code, 220.11 is going to give you how to do the dimensionals, but 220.14 J is going to tell you that it's 3 VA per square foot, by the way. Okay, so those that are studying in your code book, those are 2 really good sections to keep in mind is you're going to probably have questions that are going to be something on 220.14 J. Okay, because J has been a little bit restructured, and it pulled some of the stuff from 220.12 from the 2017 code, and that was the 3 VA per square foot and all that, and it dropped it into 220.14, okay, J. So just be aware of that. If you're in the 2017, just be aware that it's in 220.12, and then 3 VA per square foot is in the table 220.12. So again, kind of a twofer for you there. I will say these tonight are based on the 2020, but I will do my best to try to convey the 2017 as well for those that are, getting ready to take that test as well. Also, for those that are in Texas, you've got one more month to get it done on the 2017 code. Starting November 1st, it immediately goes to the 2020. So if you're studying and you're putting it off, don't put it off. Otherwise, if you've been studying the 2017 and the 2020 is going to come up, they're not going to give you an option, okay? They're not going to say, well, I'll let you do the 17. Absolutely not. They're going to cut it off, and you're going to have to do the 2020. Just as a public service announcement. All right, let's look at a different question here, guys. Let's see, I see the questions better. Squint. Let me see. What does it say? Okay, let's look at number 3. So number 3 says a homeowner wants to add. Now this one a lot of students get this one wrong. So I want you to, this is one that I would love to see on exams. Think about this now. It says a homeowner wants to add 12 general purpose receptacle outlets to the electrical drawing before the house is built. What additional load in VA will they add to the service load calculation? Now, fast track students, hold off for a second. Okay, Brian, James, Tim, hold off for a second. See if anybody out there wants to chime in. I know that there's 26 of you out there, at least right now, who are studying or coming to visit with us to study. Give it a shot. Don't be shy. I know you're sitting in the background and it doesn't matter, Come on out. And again, this is the only way we do this. These guys will tell you I try to do this usually every week. Chime on in. It's okay to be wrong. It doesn't matter. We're learning. Okay, so it's okay. But this is an interesting one that people get wrong a lot. Because if, and let's wait. Let's see if I get any answers first before we go into this one. And while you're thinking about this, I'll bring another scenario in. If you have your house, let me ask you the same question. It says Jay's not with us tonight, but Jay's, basement king. Jay does a lot of basements, and he's also a fast track student. And okay. Katie gave it a shot. Thank you, Katie. Come on, people, chime in. It's okay. It's okay. Because this is how you learn. And once you learn, you'll never miss it again. Promise you. Okay, so hang in there, Katie. Don't jump off. So we're going to finish this lesson on this one. But anyway, while I'm giving time for people to post, there you go, butterfly farting. I keep. Do they really? I mean, I've never known I can't hear if a butterfly farts, but I guess it's truly possible. So think about this one. Let me spin this one in a different way. So, Katie, let me spin it for you in a different way. Question 3, Kevin. So a homeowner wants to add 12 general purpose. So I'm wiring a house and I'm pulling my wire, and the homeowner comes up to me and says, "Hey, Paul, I want to add another one here and another one here and another one here and another one here." And of course, I'm thinking, cha-ching, change orders. But in the scheme of life, is it going to change my calculation? Is it going to change what I did for the service? Think about that for a second. Next on question 3, what if you have your house and you have an unfinished basement? It is adaptable for future use, is it not? It's an unfinished basement. And I kind of gave you a hint there where we're going with this. So it's unfinished. But let's say I want to finish my basement off. Are you telling me that if I add extra receptacles and some lighting, general lighting down there, that it's going to add load to my house? And you're thinking, well, yeah. Well, how is it exactly going to add load? Because you're already required by the NEC to do 3 VA per square foot using the outside dimensions. Okay, Bill, thanks for chiming in, Bill. That's what I'm talking about, guys. You got to chime in. Excellent. I'd much rather see you chime in and be wrong than not chime in at all. I mean, after all, you took valuable time away from your families to be here. So let's all chime in and enjoy doing this, and maybe we all learn something today. All right, so here's the trick. 3 VA per square foot already covers the outside dimensions of the floors. Since the basement is unfinished, let's say I had a basement that's unfinished, but it's still adaptable for future use. So I still have to count that measurement floor area in my 3 VA per square feet. So at 3 VA per square foot, it doesn't really matter how many receptacles I put in. Now that's going to mean you got to have the certain number of circuits to obviously to accommodate them. And of course the code doesn't tell you how many receptacles or outlets, receptacles with outlets with receptacles in them that you can have on a circuit. It really doesn't care in residential. But I think what many people are thinking is it's 180 VA per strap, and that's for commercial, that's not for residential. So in this case right here, it absolutely adds 0 additional VA to the calculation because you're already doing 3 VA per square foot. Just because they want to add some general purpose receptacles. One thing that put the 2160, Bill and Katie, go back and look at 220.14J, and you will see that 3 VA per square foot covers all general use receptacle outlets. So they're already factored in. So that way, if I do a 200 amp service, let's say I sized it and I'm doing a two floor, you have a basement that's unfinished, and I have the first floor, and maybe it's a rancher on a basement, and it's unfinished. Panel's already in, everything's done. When I go back and finish out that basement, I'm adding more circuits, but I'm not really adding any more load theoretically to the service calculation because I already figured in 3 VA per square foot. Just so that I wasn't using that space right now is irrelevant. So in this question right here, if a customer asks you to put a receptacle here, receptacle there, receptacle over here, I need another one upstairs, oh, I don't like the spacing over there, it's not going to change the load. It's still 3 VA per square foot. So the answer to this one is 0. And I very much could see something like that on an exam. Okay? So what should tell you is the fact that it says general purpose receptacle outlets. Okay? Should be the dead giveaway for that one. Okay? It's a good question. It makes you think a little bit, and that's what it's all about, right? Making you think. Okay? All right, so let's do let's do number 4, since we're at it. And I can't tell where my mouse is, guys, because it's just all wonky tonight. Number 4, it says, in each dwelling unit, the feeder load shall be computed at blank VA for each 2-wire small appliance branch circuits required by 210.11c1. So give me a code reference and give me what the VA value is that we're going to use for this feeder load. Okay. So when this says, so while y'all are thinking about that, so notice in this question, and remember, if any of you watched my video on how to dissect the root, so it's a must watch if you're preparing for an exam. You'll notice that in this one, you see it says in each dwelling unit, which tells me it's a multi-unit building, and a feeder is feeding that dwelling unit. So you still have to calculate the load in that individual dwelling unit that's going to be supplied by that feeder, and you still use the value for that unit when you're sizing the overall service. So again, you just take all the units. But in this case, we're only worried about that one unit. Could be 15 dwelling units in this building, but we're only worried about that one unit. So it says in each dwelling unit, a feeder load shall be computed at blank VA for each 2-wire small appliance branch circuit required by 210.11c1. So tell me what the VA is and tell me which code reference tells me that. Very much kind of a question that you might get on an exam. Just wants to see how you're doing it, where you're looking at things, how things are coming out. Sorry for my dog there. He doesn't cooperate well on audio night. Okay, so think about it. I'm going to open it up to any of you, even the Fast Tracks folks, the ones that are in the program. Well, we all know that in a load calculation, there's some critical things that we have to take into consideration. First thing we do, and you look at that on our form, okay, this form that we have that you should print out of your program if you're in the Fast Tracks, of course, is it's going to start out with the general lighting, then it's going to move to the small appliances, then it's going to move to the next item on the list, okay? And then you get to apply some demand factors, obviously, at that point, if you're dealing with a one-family dwelling or dwelling units. So, in this case, let's just talk about the one dwelling unit. There you go. Okay. Little off junior, because we're talking about the small appliance branch circuits. Okay, and we're in a single family dwelling, or in this case, a dwelling unit. So 220.56 isn't really going to be geared towards the actual feeder in the dwelling unit. Okay. There you go. So when I think about this, when some people say to me, Paul, do you have to remember everything on an exam? And my answer is no, you don't. And we don't expect you to remember everything. However, people that ask about the Fast Tracks, and I can only refer to that because I'm intimate with it. So you have to bear with me. If you're not in the program, I apologize. What's wrong with you? Why aren't you in it? But if you're not, there are some things that we do that are repetitious to try to reduce the amount of time you have to spend on a question so that you buy yourself some time. People have heard me talk about the wave techniques and everything. I've been talking about that since back in the early 2000s. You just got to remember that the small appliance branch circuits, you have to have a minimum of 2. Okay, that's 210.11c1. And then when it comes to the load calculations, you have to remember that everything is in 220, and this is dealing with 220.52a, and that says that each one of those small appliance branch circuits have a value for a calculation of 1,500 VA for each one. So I've got to have a minimum of 2. So that would be 1,500 each, so 3,000. Important to remember, especially if you get asked a calculation that wants to know the demand factor for a dwelling, and it gives you just enough information for you to be able to calculate all that out. And we're going to do that in a little bit. Okay. So in this question here, the answer is 1,500 VA. The answer is 220.52a, and it's going to tell you that it is 1,500 VA. Just remember, 1,500 VA for each small appliance. Okay. 1,500 VA also for the laundry. Okay. And that doesn't mean the dryer. Okay. Dryer is not part of the laundry. Okay. So it happens to be, goes in a laundry, but of course, it's not the laundry circuit as required by the National Electrical Code, by the way. So anyway, just remember 1,500 VA is what you'd use for small appliances and what you'd use for laundry, that type of thing. Okay. Just remember that. All right, let's do the next one. Let's do, and my head's not blocking that one, so we should be okay. Another one that students tend to get wrong. Some of them have a little trouble on this unit, and that is number 5. Give it a shot. It says, what is the demand load? Okay. And when you see that, it means that something has to be applied. When I see the word demand load, it means that I've done some type of calculation to get me to an actual load. In this case, the load's going to be in kW, right? So it says, what is the demand load for the service? Okay. For 3.5 kW wall-mounted ovens. And remember now, it's not asking you about a branch circuit, okay, yet. Just stick with me here. It says, what is demand load for the service for 3.5 kW wall-mounted ovens and 5 kW mounted cooking unit? All the appliances are supplied from a single branch circuit and are located in the same room of a one-family dwelling. Okay, that last information is just simply there to throw you. Trust me, it's simply there to throw you. If we were doing and sizing a branch circuit, that would have some relevance. Okay, so this is interesting. I do teach people to do this. Now, some of my private tutoring things that I do with people, one of the ones I do is when I really notice a student is struggling with separation and trying to find portions of the question that actually doesn't mean bubbly squat. This is a great example. It wants to know a demand load calculation. It's acknowledging the fact that the code allows you to feed 2 wall ovens and 1 cooking mounted. If you're sizing a branch circuit, it allows you to treat that like a single range, right? That's not, and that's fine, but that's just extra information. For us right now, what's important is that we want to know what's the demand load for a service for 2 3.5 kW wall-mounted ovens and 1 5 kW counter-mounted cooking unit. What is the demand? Work it out, guys. Let me see what it does for you. Now, the branch circuit stuff's great, but that's not what it's asking you. It's asking you for the service. That should be your first trigger. And of course, with that trigger, that means that I get to use a specific table in the code, right? Okay, but you got to know how to apply it. So see what you can do it. And you also have to know that there are notes involved that you have to be aware of. So let's see what your guys come up with. Oh, I will ask again, fast track students, hold off for a little bit. And, because you might have seen this and you've answered this one and we've already gone through this, but let some of the others in there that might not be familiar with this, because this is indicative of a question that would very much appear on an exam, right? So, and we're going to look at the code on this one, okay, as we go. We're going to really dig into it. But again, so number 5, for those that are watching, number 5, for those that are in the fast tracks, you can type it all in and have it ready. Have it ready. Brian already did it. Look at that. He didn't listen. So, but again, there's another way to do this. As you students are going through this, don't look up at the chat part. Just look at the screen and answer the question, and don't look at what other people chat until you have your answer, right? That's probably the best way to do it. Until you have your answer. Hey, Brian didn't give the answer away though. So nobody's given the answer away yet. So, oh, good. So best way to do it is just don't look at the comments until you find the answer and then post your comment in there. How about that? Brian Jr., absolutely right. Obviously, y'all are in the right track. So we got to look at it, see what we're doing. So let me write this down so that I don't lose it, because I ain't getting any brighter over the years. So let's see. I'm brighter than last night's debate. I can tell you that right now. I ain't no doubt about that. But anyway, so we got 1 5 kW. Okay. All right. So I've got 1 3.5 kW and I got 1 5 kW. Okay. I've got that answer. All right. Everybody a little time to look, and I'll go on. Got the question? Everybody write down the question, or you know what we're talking about. So let's go to the code. That ain't the code, obviously. Hold on. Got the wrong one up. There we go. That's my timer, folks. Okay, so let's go to 20. Oh, before anybody asks, this is on online edition. This is the online. They're not, NFPA is not doing a PDF version anymore. Okay, they're not. You have to pay it. You have to do a subscription version to do anything. Okay. And I don't have y'all's chat. I can see your chat, but y'all all can't see the chat. So it's we'll just start out first. All right. So first thing we're going to notice. First, okay. First thing we notice is that we had 2 3.5s and we had 1 5, right? Right? You with me? So what column are we under? We're into B, right? Okay, I'm going to be under B. And we're going to say, okay, well, I'm going to compare. I can obviously compare this to C, right? C for 3 units. Okay. It's 3 units, by the way. So the number of appliances, 3. So 3 would be 14 kW under C. Okay, so we always have to compare C to whatever, but we do notice what? That these 3 fall firmly under column B, right? So you look at C, you write it down, okay? And then we look at B, and we say, what are we doing under B? All right, so, and remember, we're not doing a branch circuit now. We're not hitting the note 4. We're doing a load service for the service, so that's where people get confused. All right, so under B, it looks like it's 55% is the third one. Again, I'll follow with my, oops, hold on, guys. I want to make sure I forget which one I'm at. Right here, 3. It looks like 55, so write that down. Just write the 55% down. It'll help you. Okay, now let's just go down really quickly. Now, check note 3 here. It says over 1 3/4 through 8 3/4. Note 3. It says in lieu of the method provided in column C, which again, we saw that one. I think that was 14 kW. So in lieu of that, meaning I usually always use column C, but when note 3 applies, then I guess what? I can do something else rather than using column C, right? So it says it shall be permissible to add the nameplate ratings of all household cooking appliances rated more than 1 3/4, but not more than 8 3/4, and all of these are falling within these ranges, and multiply the sum by the demand factor specified in column A or column B. Now, okay, for each given appliance. So there was 3 of them. Okay, so let me see where I'm at on my screen. All right, you with me? Okay, so first thing I'm going to do is I got my scratch paper, and I got 3.5, 3.5, and a 5. So we're going to add them. It says right there on note 3, it says 3.5 plus 3.5 plus 5 equals 12. Okay, 12. All right, now, that's 12. But remember, it said I could apply what? 55%. So I do 12 times 55%. Oops, excuse me, times 55% is 6.6. So it's 6.6 kW. Okay, let me go back to us in the browser and see if anybody came up with that. Nobody came up with that yet? Okay. So I probably should have waited a little longer and let y'all do it a little more. But sorry, I'm impatient and I just wanted to do it because I love calculations. No. So because this one fell in column C or note C, you're simply adding together, okay, the values because they all fall under C. And of course, I compare that to C, and C is at 14, so there's no way we want to use C. We're going to use column B, baby. There's no way we're going to, okay, use the lesser of the 2. And so in this case, it's 6.6 because you simply added 3.5, 3.5, and 5. And then you multiply that by the percentage. In this case, it was 3 of them, so it was 55%. And that's how we got 6.6 kW, and that is the answer. Okay? Everybody kind of square on that one? Very much might be something that you get on an exam. Very much. Anybody have any questions about that one before I move on to the next one? Somebody let me know at least y'all are still there. Here, I'll do my own little thank you, and that'll tell me. There I go. We're still there. Okay, at least I think we're still there. Y'all are just an extremely shy bunch. So there you go. All right. Let me throw that one away, and we'll go to the next one. I find that a lot of people get kind of stressed out about range calculations, and it really is if you slow down and you really pay attention to the notes, and just remember you use C any other time, and you'll use C with note 1 and 2, and you'll use C except when note 3 applies, and then you get to compare C versus whatever column, A or B, okay? So just kind of keep that in mind. Hey, Elwood, you missed a lot, buddy. I can't re-go over it all, so hopefully you'll watch the rebroadcast. We've been answering questions 2, 3, and 4, and we just did number 5. So we were just kind of looking at some stuff that's actually in one of the, I'm kind of broke tradition here. One of my big traditions is, and only second time I've ever done this, is we're actually looking at one of the competency reviews that students find the hardest. So if any of my students that are in this and you get up to U to date, I expect really great scores because we're giving you some answers here tonight. Okay? Hopefully you get really, really good scores. All right, so let's move up a little bit. All right, let's look at, hold on, let me go down a little bit. I went too far. Okay, let's look at number 6. Okay? Question number 6. There you go, Elwood. You can pick up right here with us. So number 6 is not as challenging. Most of the students get this one right, I believe, for the most part. But let's give it a shot. And again, thinking out loud, chime in. Don't be shy. Feel free to answer. If you get it wrong, it's okay. Ain't nobody going to jump on you. This ain't like some of those other forums online where they're like, what, you didn't know that? No, we don't need to know that. That's why we're working on it, you moron. Don't let other people get under your skin, okay? Okay, we're all learning. Everybody had to learn, and we never stop learning. Never stop learning, okay? And I'm also not always politically correct. So again, if I offend anybody, I don't mean to. It's just me. All right, so the next one, number 6. So we've got a 4.5 kVA, 240 volt electric clothes dryer. Incidentally, remember that clothes dryers aren't required, but if they're in your calculation for an exam, you have to take them into consideration. But again, they're not required. You're not required to have a clothes dryer in your house, but most people put one in. But anyway, so let's see, 4.5 kVA. K stands for 1,000, VA is volt amperes, so 4.5 is the same as 4,500 VA. And another hint, when you're doing a calc, I always like to try to take all the way down to the basic level function, and that is in VA. So if I was doing this calculation out, for example, and I was just trying to find what the amps were for something like that, or something in the calculation, it would be 4,500 is what I would use, and then the 240 volt, okay? But in the question, it's 4.5 kVA, 240 volt electric clothes dryer contributes blank amperes to the neutral load when calculating the service by the standard method. Very good question. And many people get this wrong. So when it comes to rounding, when you get a question like this about the neutral load, it's asking you what the actual contribution is, not a rounded value. That's an assumption of what the value is. Although, a lot of times we will, exams will accept it, but it wants to know what is the contribution? What is it? So if I have a certain value and I round it, that's not necessarily the contribution in the way this question is asking it, okay? So in this case, it wants to know what the neutral load is. So you all know that when you're doing a standard method, that's pretty straightforward. You're going to size your ungrounded conductors and your grounded conductors. You're going to do everything norm. When you're using an optional method, and here's where people get confused. If you're just working this question out, please work it out, but then listen to me as we talk. One of the things that people tend to do is they think if they do the optional method and they're sizing the hot conductors, the ungrounded conductors, and then I tell them they have to use the standard to do the neutral, they for some reason think that the ungrounded conductor comes back into play again, and it doesn't. You've already sized that for the optional method. That's done. The only thing you're doing in the standard method is dedicated to the neutral loads. That's it. Okay? You're not trying to size an ungrounded conductor. You're not trying to follow any of those rules. You've already done it in the optional. You're just using the standard to size the neutral. A lot of people seem to get that confused. When I say, okay, you got to use the standard method for a neutral calculation, they think you have to do the whole calc. It's good to do the whole calc because you got to know which loads are 120 volt loads. But again, you're just trying to solve for the neutral. That's it. Okay. And these forms, again, y'all saw the one I talked about earlier, these little forms that are in the Fast Tracks program. Again, you can't see it. There you go. Really make it easy. Okay. For you to be able to do that. Okay. I don't know any dryer that, well, hold off on that. Keep that thought. Okay. The contribution. Keep that thought. So think about how you work it out and how you get your values. Okay. The first thing I will remind you, though, and I will help you out, June. First thing I'll remind you is, since we're doing the standard method, because it says use the standard method, let me do something real quick. Can you use 4500 VA, June, if you're doing a standard method for a dryer? So this question is for June, so I can help June in this. Can you use 4500 VA in a standard calculation for a dryer? Yes or no? Now you put 4500, so but hopefully you're going to have an epiphany here in a second, and you're going to go look at the code reference that deals with dryers, and you're going to come back to me and say, so we'll see. And of course, you got a couple other things in there a little bit off, but ironically, the overall value is you're pretty close. You're pretty close, but I want to make sure we see the full method on how you would do this. So Katie says 3,500. I hope that's not 3,500 amps, Katie, because that is one hell of a dryer neutral load. That's massive. I am not buying that house. I'm just saying. It cost me a fortune to run the circuits for that bad Bama Jamma. I'm just saying. Just teasing you, Katie. I like the fact that people are chiming in. That's what I like. That's what I like about it. Otherwise, it's just me talking, and what's the point? There's 30-some plus people in here. I expect to see 30-some people chiming in. At least let me know who's here and where you're from. Okay, say holla. Okay, I'm going to give up my time for you. I want let's communicate. That's what we're here to do. I want to help you. I want to make learning code fun. It doesn't have to be dry and dull. All right, so let me get to this question. First thing we know is 220.54 tells us that we have to use 5,000 VA or the nameplate, whichever is greater. In this case, it says 4.5, so we know that we have to use 5,000, okay, or 5 kVA for this. All right, we know that first. All right, we all square with that? All right, so if we were doing an optional method, the optional method, then we would take the straight value from the clothes dryer, wouldn't we? But we're using that last line. It says standard method. So we want to make sure we know that 220.54, and we're going to use 5,000, right? So let's get our little patty wax down. Okay. So since asking for the amp contribution, right? So the first thing I'm going to do is write 5,000 down, okay? And I'm going to divide that by, do a little Ohm's law here, a little EIR work, okay? I'm going to take that 5,000 and I'm going to divide that by 240. And that's going to give me 20.83. Okay? Let everybody see that on the screen? Okay? All right? We only use the nameplate value on the optional method, not on the standard method. So 20.83. Okay? Now, what did it tell me in what? What does it tell me in 220.61b? Do we need to go to it? Let's go to it real quick. All right, so we're over here in the code. I can't remember which one my code is. This is the code. So here's neutral and feeder neutral load. So here's A and here's B, permitted reductions. Note that it says a service or feeder supplying the following load shall be permitted to have an additional demand factor of 70% applied to the amount of 220.61b1 or portion of the amount in 220.61b2 determined by the following calculations. Well, we're not talking about 2. We're talking about this one, 1. And it says a feeder or service supplying household electric ranges, wall-mounted cooking ovens, counter-mounted cooking unit, even induction units. Again, don't let that fool you. Simply a counter-mounted cooking unit. And clothes dryers, where the maximum unbalanced load has been determined in accordance with table 220.55 for ranges and table 220.54 for dryers. Okay, but we only have one, right? So for our dryers, so when 1 to 4, it's 100%. Okay, so we're allowed to apply the demand factor, and we're trying to find what and let's go back to now. We know that we can apply the 70%, right? You with me? So let's go back to the question. I love my little switcher. That is so almost professional looking. Anyway, so we had 20.83, right? So now what do we want to do? Remember the question? Question says it wants to find an amp value. We already calculated amps, so we get to apply 70% of this, okay? Now, you could have done the same thing by applying the 70% to the VA, and you would have still come up with the same thing. But it's easier to solve it for amps and then apply this rule to the amps. Okay, so 20.83, and we're going to do that times 70%, and that is 14.58. And so 14.58, you could drop 3. So in this case, it wanted to know what the actual contribution is. If I were to round this to 15, and for some students, I will accept the 15. I'm like, okay, you know what? For real scheme of life, not a big deal. But in reality, the most correct answer is 14.58. Now, on an exam, if they give you 15, 14.58, 16, then the most accurate answer is 14.58 because that is the actual contribution, okay, on that neutral, okay? I took the 70% from the actual ampacity. So you take the 5,000, which is what you have to take from 220.54, okay, 5,000, 5,000, and I take that and I divide it by 240 to get me amps, right? And that is 20.83. Once I have the amps, since the question is asking about amps, then I take the 70%, which afforded me in 220.61b, to be able to say times 70%, and that's where I got the 14.58. Now, let's do it a different way. Let's say I were to take the 5,000, and you want to do it this way. Some people do it this way. Do the 5,000 times 70%. It's 3,500, which is probably what, probably what Katie was talking about. But once you get that 3,500, then you have to divide that by 240, and it still gives you the 14.58. So that's the beautiful thing, okay? Yeah, well, you got to be a little more direct than that, Kevin. You can't put 13 through 15 amps. I mean, really? Really? You daggone right I'm going to mark it wrong because there's an actual answer, 14.58. So anyway, there's 2 ways to answer that one. So that's the beautiful thing about the calculations, okay? You got 2 ways you could have done it. You could have done it off the VA, or you could do it off the amps. I have a tendency to like to do things off the amps for that questions like that. But again, both ways work. Apply the 70% either to the VA or apply it to the amps. Isn't that a beautiful thing? It works either way. All right, next question. Doing good tonight. All right. Let's see here, guys. Let me go to the next one. And I'll scroll up because people can't see. All right, number 7, I believe we're on, right? Oh, I did it again, folks. Can't really see the same. That's why I have to keep looking down, because I can't see the same screen as y'all, because I'm doing something a little different. I got multiple screens going on, monitoring Facebooks, and I don't have anybody on here from Facebook, by the way. So I'm assuming that stream isn't working. So anybody that jumps over to Facebook to check, assuming that stream is dead. So let me go on and kill Facebook. Okay, I killed the Facebook stream. Just got you folks over here on YouTube. Anyway, I like YouTube better anyway. All right, so number 7. Let's work this one out. Now, this is where it's good to have this sheet. Okay, but yeah, it's okay. We'll work it out. For those that don't have the sheet, I'll try to keep it simple. These are very much questions you'll see on an exam, folks. These type of things. So that's why we're doing it. That's why I chose Unit 8 tonight. All right. A one-family dwelling contains the following appliances. Let's write these things down. Okay. Always write them down. A 1 kVA 115 volt dishwasher. So 1 kVA 115 volt dishwasher. I like writing stuff down. Just me. Okay. Number 2 is a 4th horsepower. So I'm going to write this down. 1/4 horsepower, 115 volts. Remember, always use what they give you in a question. All right. Kevin, no, because 4500 VA, we're using a standard method. Standard method 220.54 says you got to use 5,000 or the nameplate, whichever is greater. We wouldn't use that. 4500 would be optional method, where that question wanted you to use the standard method. Got to be very careful. Make sure you understand the difference. Okay. All right. So what do we have? 4th horsepower, 50 volt in sink waste disposal. So let's just say it's a disposal. Next we have, what is that? 1/3 horsepower. God, it's hard to see. 1/3 horsepower, 115 volt. What do we got? Trash compactor. They even make those anymore? My mom had one when I was younger, and it stopped working. So we just used to put trash in it anyway, but it never would compact it. I was the trash compactor in our family. Hey, Paul, shove that trash down. That's what I do. All right, so there you go. Now, okay, so that's it. It says using the standard method, what is the load contribution in VA for these appliances? None of these motors will be the largest motor in the dwelling. So again, that's just saying, that's slang for saying, no, you don't need to add the additional 25% for the largest motor. Okay, that's just slang for that. So how many do we have, folks? We have a dishwasher, we have a disposal, and we have a trash compactor. I only count 3. Is that what y'all count? 3. It's important to remember that. It's only 3. Okay. This is great. This is a great one. So the first thing you always want to do in an exam, when you get a question like this, this actually counts as a math question on many exams, okay? Because you're going to have, it's part of some math you have to do. Anytime you have some type of step in math, they have a 1-step, 2-step, 3-step, or 4-step. Like in Texas, if you have to calculate 2 things, it's a 2-step question or a 3-step question, okay? And they consider those master level. And I kind of think that they're pretty elementary, but again, they make you think. And anytime you're in a stressful environment, even a 2-step can be tricky sometimes, right? So, all right, so first thing, what do you think the first thing you have to do? The very first thing that you have to do is I automatically need to get what? I need to get the values of each one of these motors, right? I need to solve these motors, okay? So I need to get, first of all, I got to get the FLC. It's basically short for saying I'm going to have to go to 430, and I'm going to have to go, in this case, 430.248, I believe, in order for me to get the values for single-phase motors, because all these obviously are single-phase. So let's go over, make sure I wrote what I need down, and I got what I need. So let's go to the NEC. And it's the first thing you guys should do in this question on an exam, okay, is go, so I'm going to go to the NEC, and you got tabs in your code book for these tables. So you should go boom, boom, boom right there. I had somebody tell me the other day, tabs are just, you don't need them if you know the code. Come on, man. You're taking an exam. Anything that's going to shave some time off of looking up things is always a benefit. Whoa, what happened to my... Hold on for a second. Whoa, what is going on with my screen, folks? All right, hold on. All right. So I don't know what was going on. It had a mind of its own. All right. So we're looking at 430, 248 single phase. We're right here. Okay. FLC. Remember, the value that's on the motor is the nameplate value. We don't want that when we're sizing conductors, overcurrent devices, only for overloads. When everything else, we use an FLC for the most part. So first one was 4th horsepower right here. And it was 115 volts. So it's 5.8 amps. So write that down. 5.8 amps. Write it down. The next one is a third right here. And that is 7.2. Write that down. 7.2. First thing you do now. So now I have my amps. Okay. So once I have my amps, now you're thinking, well, wait a minute. And you'll come back to me now because we're pretty much done back there. So now I already got one at 1000 VA for the dishwasher. I gotta convert the other ones now to what? VA. How do you do that? It's pretty simple. All you're going to do is take the amps and you'll multiply it by the voltage. So let's do that. So let's do the first one. So it was 115 times 5.8. And that is 667. So that is the disposal. And then the other one was 115 times 7.2. And that is 828. And that is the trash compactor. Of course, we had the 1000, right? For the dishwasher, right? So you might as well write that one down, 1000 for the dishwasher. Okay? Now, let's add those up. 1000 plus 828 plus 667 equals 2,495. So if I had to answer the question, it's simply asking under the standard method for the load calculation in VA for these appliances. All right. Now, if you had 4 or more, then you could have applied a demand factor of 75%. But we only had 3. So don't get tricked up and apply a demand factor of 75% because you didn't have 4 or more. Now, on our nifty little fill-out sheet that we have that's in the Fast Tracks program, it tells you that. It says right here, if 4 or more, multiply by 75%. If fewer than 4, the total VA amperes on line 10, so it's basically just you add them up and that's it. So to answer this question, 2,495 VA is the answer to question number 7. Of course, the code references, again, we only make you put 1 in the Fast Tracks, so it would be the application of the appliances. But again, you could also have put in there 430.248. We'd allow that, okay, as well. So, but most of the time it would be it's going to be 220.53. 20.53 for that one, okay? You just don't add the 75% because you didn't have 4 or more. So that is a question that people get wrong simply because they immediately remember that I get to apply a demand of 75%. And the answer to that is no, you don't, because there was only 3 of them. Look for those things on an exam, folks. That's written in a way that it could be tricky for you if you stop and you're getting rolling and you forget about it, right? Okay. Let's do the next one. Help me out. Number 8. For one family dwelling, the service disconnecting means must have a rating of at least blank amperes 3 wire. Okay, so it's basically an SEU coming in from the overhead, let's say, coming to the weatherhead, dropping down to the meter, coming, in the 2020 code, now you're going to hit a outside service disconnect, emergency disconnect. And then your feeder is going to go into, could be a feeder going into the actual panel, but coming down and supplying it. Oh, hold on. It's going to cut me off. Sorry about that. Man, I'm glad that popped up. All right. So somebody look that one up in the code for me. And you should remember that there is a minimum ampere rating for a one family dwelling. And these are one of those ones on an exam where you're like, I should get this right. First of all, dissecting the question, it's a service disconnected mean, so you know this is in service. This is something in services. Okay? So let's see who will answer this. And fast track students, feel free to chime in and answer this one if you want. So, because this is a value that you really should remember, because it is the minimum size that you would have for a single family dwelling. Now, of course, you could have individual dwelling units that this wouldn't apply to, like in apartment buildings. Okay. Tree, there you go. Very good. Kevin, very good. Absolutely. So 230.79c says that for one family that you're going to have, for one family dwelling, it's going to be at least 100 amps. Interesting enough, it could be less than that for an apartment, could be 60 amps for an apartment. Okay. I believe that is 230.79d, I believe, for that. All right. Very good. That one's a little too easy. So let's go to the next one. Now, here's some of the ones that probably is going to be one of the something that you might see on an exam. Okay, so buckle up, get your code books, get your pens, get everything ready. Number 9, a one family dwelling has a 175 ampere, 240 volt service that is fed with 75 degrees C conductors. And that is obviously, important information there. What is the minimum size copper grounding electroconductor required? All right, this one makes you do some steps, and you would think, oh, this is easy. Well, remember, we can't size that grounding electroconductor until we know what size the conductors are that supplies it, and right now, we don't even know that. All we know that they're rated 75 degrees C, and it's 175 ampere. Now, remember, one family dwellings, you always want to solve it for the lowest possible answer, which we translate in the testing world as the best possible answer. I never want to size a service larger than I need to. You can, but I don't want to pay more than necessary. I don't want to upsize something just because it gives me the warm and fuzzies. If I calculate it out and it's fine, I'm happy with it. Okay? Not everybody agrees, but the way the code looks at it is it's acceptable to do something. Then if it's acceptable in the code, then you can use the code. So on an exam, always figure the best possible answer. So this is a very good question because it's going to make you do something first before you can even begin to answer this question. All right, so give it a shot. Number 9, I'm not going to let y'all fester in it too long. I'm going to give it a shot. So it's a one family dwelling. It's a 175 ampere, 240 volt service that is fed with 75 degrees C conductors. So I'm going to do it with you. Okay. I do these all the time, but I'm going to do it with you. I'm going to look at it and say, well, I know something very unique about this because it's a one family dwelling. The service size is between 100 and 400 amps. It's a 240 volt service. So we know it's what? 2 hots and a neutral. Okay, something's adding up in my mind. Hopefully it's adding up in your mind. That 75 degrees C conductors helps me once I get to that point. What can I do? What do I need to do? Okay, so think about it for a second. Give it a little thought. And let me see what you get. And while y'all are doing that, the brains are working. I can feel them working. I'll go over to the code section. And again, I'm in a 2020 edition. Brian's giving everybody a hint. So don't y'all go cheating and looking at Brian, but Brian is giving y'all all a hint. Kind of how to think that. of what you do. I'll go on and go to the code and go there, kind of help y'all out, because this is one that I would expect to see on some exams maybe, and you just need to know how to do this. Okay, so let's go to the NEC. All right, and I'll go back to the top for those that are watching. Okay. Oops. Sorry about that. Clicked the wrong button. Okay, so it is a little different in the 2020 than it is in the 2017. Okay, but same principles. Okay. Giving you any hints here on the screen. Okay, this kind of chimes with what Brian was saying. Okay. Now, in this question, I didn't give you anything about adjustments or anything about corrections. Nothing. Okay? Didn't tell you anything with that. Now, here's the difference. In the 2017 code, I'm going to make you calculate it. In the 2020 code, we're going back to the cheating world. We're going to give you the little table. My goal is to make sure you know how to calculate it. Okay? That's my goal. My goal is that you guys know how to calculate it. So, how you calculate? You can go to the table, but in the real world, you take the rating of the breaker. In this case, is a 175. And I do a 175 times 83%. Okay? So, in our world, you're like, okay, where I'm sizing and what I'm doing is to make sure that I'm going to have a conductors that has to be at least 83% of the rating. Okay. So 175 times 83% is 145.25. Okay. Of course, you could cheat. You know what? I'm not going to call it cheating. It isn't cheating. It's right here. But I wanted to show you how to do it. 175 requires a 1/0. Okay? In this scenario, it has to be the size of the ungrounded conductors. Okay? That's the hot. And then you take that and then you go to 250.66, right? But I want to show you how to do this if you didn't use this table. So we got 145.25. Remember, it was 75 degrees C conductors. Then you would go to 310/16 right here. And 75 degree, remember it told you that? And you go down, and I need a conductor that's good for 145.25 because it's got to be at least 83%. And 1 gauge is not good enough. It's only good for 130. So I'd go to 1/0, which is good for 150, which is more than 145.25, so that is your answer. So once it's 1/0, then you go to table 250.66. Hopefully y'all are following along with me, and I'm moving quickly, but I think y'all get the gist of it. So here's 250.66. Once we know 1/0, then the size of the EGC is going to be a 6 gauge. And so the answer is going to be a 6 AWG. Okay? But a really good question for me to show you how to use 310.12 or 310.15B7, okay, if you're in the 2017 code. Okay? So 310.15B7 in the 2017 code, it's not new, just been moved. But in the 2020, it's 310.12. And the difference is the table came back in the 2020. Now, in the 2017, it's still in the book. It's just you got to go back to Informative Annex D. Okay? Got to go to D. Now, one little caveat, folks. Let me go and tell you this while I'm teaching people. That table is great right? If there's no adjustment and corrections involved. The table's wonderful. But the moment you throw an adjustment or correction into the mix, that table's no good anymore. So then just forget the table. So the conductor still at this point would be 83%, but then you would treat it like you did anything else. You would apply adjustment and corrections to it so that at the end of the calculation, I still have a conductor that's good for 83%. Okay, so that means you would go up in size in order to apply the adjustment and corrections so that you at least have a conductor that's 83. You can't get rid of the 83%. Okay, it's got to be at least 83%. But if you've got ambient temperature, or if you got a number of current conductors that exceed 3, then that table's no good to you. You still use the 83%, but you're going to use 31016, the ampacities, and you're going to treat it just like we do in derating demystified. Okay, great stuff to know. If you don't understand derating demystified, go watch that video. It's a free video. It's on our not on our website. It's on the YouTube channel that you're on right now in the calculations folder. Okay. Hey, Carlos, welcome. Welcome, welcome, welcome. Thank you for coming. Thank you, Carlos, for joining us. All right, so that's how you do it. That's a powerful lesson. Hopefully you got it. If you didn't, go back and watch this later and you'll get it, and watch it again and again and again and again and you'll get it. All right, let's move on to another question. Number 10. Okay. So number 10 is one family dwelling. Let me get my pencil out here, my pen, so we can work this one out. All right, so I have a one family dwelling, okay, has 6 3 kW electric wall heaters, each with their individual thermostat. Okay, so it's typical like strip heating like we normally would have. So I've got this, I got 6 of those. So it's 6 3 kW wall heaters. Okay, they each got their own thermostat. Okay, cool. I've got 5 room air conditioners. Okay, I got 5 overall. Okay, so what is that made up of? Well, it says I got 2 air conditioners rated 10.5 amps. So I've got 2 of them at 10.5 amps. Okay, at 230. Okay, easy enough. And the others, which tells me that I've got 3 at 7.2 amps. So that's 3. And they're not giving you the numbers like that because they want to throw you here. And those are at 115 volts. Okay. It says a service calculation is being performed using the optional method. How many VA should be included after demand factors for the heaters and the air conditioning? Assume heaters KW rating is equivalent to KVA. See, I always remember that. So KVA is synonymous with KW back and forth when we're doing these calculations, okay, in this area of Article 220 for what we're working with right now, okay? So let's kind of work this thing out, if you will. I got my notes here. Y'all work it out with me together. This right here is not an easy one because it's telling you to use the optional method. Okay. And in the optional method, you have, when you're doing heat versus AC, you got 6 different options. Okay. So make sure you're looking in the code. You're looking under part 4. You're looking at the optional methods, and you're looking at the bottom part when it comes to heat versus AC. Okay. So look at it. All right. So let's kind of work this out. I'm going to work it out with you. Don't worry. Don't stress. So I've got 6 units for heat. So that would be 6 times, and they're 3,000 each, right? So 6 times 3,000 equals 18,000. Okay. All right. And so we've got that. And hopefully you're working it out with me, folks. Work this one out with me. The only way you're going to learn. Remember, we're doing optional method. All right. So let's see here. They're all separately controlled. That's important. So let's see here. So let's see what it says in our calculations. Let's go to the code book. Hopefully y'all jotted those down. So we'll go to the code book. And I'm at the code book and make sure I got it. Yep, there we go. Let me get out of this. Just follow along with me, folks. Let's go 220. Oops, went too far. All right. Oops. These things always throw me. Okay. All right. All right, so when we're doing the optional method right here, hopefully you can see that on the screen. We're an optional method. Oops. All right, so the general loads were, again, all those things, 3 VA, 2 small appliances, nameplates of everything. Again, that's easy. That's the easy part. So what we're going to focus on is this part. Right there. Okay, now, first thing I'll notice, let's talk about that heat real quick. So, because I got to compare. We know we got to take the AC at 100%. We can leave that for a second. We'll do the heat because that's the harder. So 40% of the nameplate ratings of electric space heating if 4 or more separately controlled units. Well, there were 6 of these things. So I can apply 40%. That's a beautiful thing. Trust me. So that would take that 6 times 3,000 is 18,000. So 18,000 times 40%. And that's 7,200. Okay. And that's 7,200 VA, because remember, watts is synonymous with VA. So we're good there. All right. So you kind of stick that 7,200 aside for a second, right? Now we gotta work on this AC. Okay. We got the heat. Heat's good. We did the heat in this case. They were strips. Those were easy. All right. Let's do the other one. So the first thing I noticed here is I had 2 at 10.5 amps. And I got 3 at 7.2 amps. All right, so let's do this. You ready? Hopefully you got your calcs with you. I'm going to go I'm going to do the 2 big ones first. 2 times 10.5 times 230. Okay. And that should be 4,830. Write that down. 4,830. And that was for the 2 larger air conditioning units. Now let's do the next one. 3 times 7.2 times, and you could do it individual if you want. You could do 3 times 7.2, get a total, then that times 115 if you want. But again, I always like to just do the whole thing out. So 3 times 7.2 times 115 equals 2,484. So I'm gonna write that down. 2,484 VA. Okay, so I've got a 4830 for the 10.5 at 230 volts, 230 volts. And again, we're just using Ohm's law, normal calculations. And we're using, the second one was 3 of them at 7.2 amps at 115 volts. So that was 2,484. Add the 2 together, okay? Not the heat. Add the 2 AC loads together, the 3 and the 2 together. And that's going to be 4,830 plus 2,484 equals 7,314. Okay? So, which is larger? Well, it looks like the heat was 7,200 VA, but the AC is 7,314 VA. So which do you think wins here? Remember, it says, right here, it says the largest of the following 6 choices here. We used number 5, and we used number 1 for the air conditioning. And ultimately, 1 was larger. So in this case, the AC won out. So we get to discount and get rid of the heat because the AC is a greater value. Okay? That's a lot. That's pretty heavy for folks. So hopefully y'all all got that. Hey, what's up, Wee? 2K17, Daniel K. Welcome to the stream. So that is a tough one, but just remember, separate it out. And this one was easy because optional method, and it went out of its way to tell you that each one of them were individually thermostated. Don't fret on an exam. You'll have 6 options. Just separate the question. Make sure you separate the heat and you separate the AC and work with whatever they give you. Okay? Just don't overcomplicate it. So a lot of the students have a little bit of trouble with this one. But again, this is the easier version of it because it didn't have like blower motors and all this, air handler and all this kind of stuff. So, so there you go. Hopefully you got figured that one out. Let's do number 11. In each dwelling unit, a feeder load of at least blank. Oh, I told you this one earlier. Y'all should know this one. I should get some answers right off the bat. In a dwelling unit, a feeder load of at least blank volt amperes must be included for each 2-wire laundry branch circuit installed as required by 210.11c2. Again, that's just a 12 gauge, a yellow non-metallic sheath cable with a black and a white in it and an equipment ground. That's it. But what's the VA and where did you get it from? Somebody throw me an answer. Y'all remember what we talked about earlier tonight, what the actual VA was for small appliances and laundry? So should be a no-brainer. On an exam, this should be pretty quick answer. If you get 50 answers, 50 questions like this, then it should be piece of cake. Okay? It'd be like, if you get 50 questions that easy, it should be like out of the park. Home run. So, but I got nobody chiming in, so either the stream is lagging or, I don't know. Not sure what it says. Maybe I've lost all viewers. Let's see here. No, I think I'm still there. Not sure. There you go, Kevin. 1500 VA. Absolutely. Absolutely. There you go. There you go. Question. You got a question, Brian? Shoot. I'm sure if you had a question or not, Brian. You did a little question mark there. If you got a question, shoot it. Let's have it. Maybe not. Maybe no question. Okay. All right. Let's look at number 12. Oh, the reference, near the same place that it was previously. Obviously, we're dealing with a 220 calculation to give us a VA value. So you're going to look at 220.52b is where you get the 1500 VA. Okay. And it's right next to where you get the one. Okay. Sorry, Brian. It's right there over where you got the answer for the 2 small appliances as well. Okay. So just remember, and 220 is going to give us the VA values. 210 is going to tell us the circuits and the laundry circuit and what you need. That's the 210 for the branch circuit. When it comes to the load or wants a VA value or something like that, always remember it's going to be in 220. All right. Let's do 12. Good class tonight. 12 says, okay, a 12 kW, 240 volt range contributes blank watts to the load when calculating the service by the standard method. Okay, let's get some answers for this one. Number 12. So I've got a 12 kW range in my house, but I'm doing a load calc, standard method. What is the contribution in wattage? Okay. What's the value that I would contribute to my load calculation for under the standard method for that 12 kW range? What do you think? Somebody throw me out a number. Let me hear you. Kevin, I like your answer. Don't like your reference. There is no PDF file for today's presentation, Carlos. You're new to this, right? So this is me every Friday night. I am literally on the fly. This is directly out of a live. This is live online. This is right out of our course. There is no, in order to get any of this stuff, you got to be in the Fast Tracks program. That's why I do it like this. Now you'll be able to watch this video again afterwards, but this isn't a presentation you get to keep. Now you can watch it all you want. It'll be up on our YouTube channel. And there's other ones up there. Oh, for all of you that are coming tonight, remind you that there are literally dozens of other ones from other Wednesday nights that we've done that you can go watch over on the YouTube channel. Just go watch them. You can find them. They're over there. They'll have under there. They'll say Fast Tracks. They're in a separate playlist, and they're all in there. Just go watch them. It's just like this, and I've done dozens of them. So again, I try to save as many as I can. So the answer is absolutely 8,000. Okay. And the reference is table 220.55. And I will show you that in the code. No June. So we're in the code. And we'll go back to 220.55 right here. The demand contribution, maximum demand, KW. Notice it says maximum demand in KW for one appliance, not rated over 12, right? And if I remember right, our question was 12, so it wasn't over 12. So since it's not over 12, then one appliance equals 8 kW. Okay. Another thing to remember is these are percentage. Oh, sorry. These are percentages. Okay, down here in this column, these are percentages. This is demand factor, the maximum demand. So I usually tell students to highlight this so that the percentage is highlighted. And then I tell them over here to do the maximum demand. So the demand is 8,000 or 8 kW. And you know me, it always should be broken down into the lowest form. So that's 8,000. Okay. So the answer is 8,000. Now, see, it says notes. Now, if it was over 12, then you got to use these notes. Okay. Or if there was multiple ones with unequal ratings that are over 8 3/4 through 27, then you use note 2. Okay. But in this case, it's just one range. One range. It's not over 12. So I can use 8. So I have some built-in demand allowances here. Okay. It's a beautiful thing, as Martha Stewart will say. All right. So just remember that. 8,000 watts, one range. You might say, but it's 12,000 kW, Paul. Or it's 12 kW, it's 12,000 watts. How can it be 8,000? Because it is, due to demands and allowances. Okay, cycling. It's all good. Now, if you're using the optional method, you need to use the nameplate. That's where people get confused. Oh, and I should mention this. I have 2 videos that are out there, folks, that are based on a webinar, that are over there for all of you that are watching, that are based on a standard calculation and an optional calculation, and I walked you through every step in that. Okay? Go watch those. If you really want to see every step of a standard method and every step of the optional method, those videos are available over on the YouTube channel. Underneath the electrical calculations tab, you just scroll down and you'll find it, and it'll say optional method or standard method. Okay? And there you go. All right. We've got a little time to do one of the more complicated ones here. Let's do the standard method. Let's try to solve these 4 questions right here. Let's try to do these 4 questions. All right, so here's our givens, folks, right here. These are our givens. And we're reminded that kW is equivalent to kVA. So again, you don't have to rethink it or rethink the wheel. Notice that we're going to answer questions 13, 14, 15, and 16. We're going to spend our time doing that before we end tonight's segment. So the first thing I would do, folks, is your scratch paper. If you get this, and you're not going to have it like this usually on an exam that makes you do all these things and give you a whole building, if you will, but they might. So just be ready to do it. Now, I remind you, we've already done most of these. In other words, we've already looked up most of these, by the way. So you should still, we'll look it up again, but you still should have the value. So the first thing that I like to do, folks, the very first thing that I like to do if I got this question, okay, is convert all of my horsepowers into VA right away, right out the gate, okay, because I need to work in VA. All right, remember, kW is equivalent to VA, but kVA is equivalent to kW. So, but I need to break it down into the lowest form. So the first thing that I'm going to do, and I see I need to scroll down a little bit. The first thing that I'm going to do is take all of these loads that are motors and get a VA. And you remember how we did that earlier? So let's do that real quick. So I have that 3rd horsepower, and I threw that away, so I'm going to have to do it again. I think I remember what it was. But it's a 3rd horsepower. And the next thing I'm going to do, and it's at 115. And then I'm doing these things in succession in my mind, folks. So you need to get that way too. So the air handler is 4th horsepower. So I need to look at that. So that's a 4th horsepower at 115. And yes, you want to use the value they give you in the question. Okay. And then the next thing, work this with me if you want. And the third one is that condensing fan motor. That is 1/6 of a horsepower. So that's 1/6 horsepower. And that is 115 as well. So remember what we do? We go back to where? 430, 248. And now we have to get what's called the FLC. Now remember, the ampacity value that's on the nameplate, that's the FLA. Okay, that's not what we need. We need the FLC. So we have to go back. So let's go and get those values real quick. See, I love walking you through it so we can walk through every piece of it. That way nobody can say, Paul, you didn't walk me through it. Sure I did. So again, this is what I like to do first. If you don't, that's up to you. But I like to, first things first, I need to get my values. So here's my table. You more than likely have a tab for that. So 3rd horsepower, 7.2 amps. Got that earlier. 1/4 horsepower, 5.8. And 1/6 horsepower is 4.4. We didn't have that one earlier. So 4.4 amps. All right, so we're done with that. Let's get back to our job here. All right, now, remember how we convert these to VA? So the first one would be the 3rd horsepower. We're going to do 7.2 times 115. Yes, you're going to use the value that's in your question. So the 1/3 horsepower equals 828 VA. Then the next one was the 4th horsepower at 5.8 amps. So 5.8 times 115. And that is 667 VA. And then we'll do the 6th horsepower. And that one is 4.4 times 115. And that is 506. All right, so by doing that, it gets me the values of a VA so I can, anywhere I need to add them, if I needed to add them, then I can do that. Now, it might not be what's in the question, but I to get there, I need to get those VAs. So do that first and make sure you get that out of the way, okay? Always want to throw that and get all of that out of the way. All right, so let's work the first thing here. All right, so how many square foot do we have of this house? 2,500 square feet. It doesn't say wood floors. That's it. Boy, if you get this question, you got to love it. You got to be like thinking, Because I mean, it's easy, right? 2,500. Oh, and that's where this form comes in beautiful, guys. Let's fill it. If you got one of these, I'll fill it out and show you. All right. I wish I could do it on the screen. Maybe I'll work on that in the future. All right. So the first box says 3 times because we know it's 3 VA per square foot. Where do we get that? 220.14J, right? We talked about it. So 3 times 2,500, and that is 7,500. Okay. So I'll show you folks too, right there. See how I wrote that down? This is why you want to use these forms. It teaches you the systematically to move through it. Okay. Remember, we're calculating for the dwelling. And the first question in 13 wants to know what's the minimum ampere rating of the service. Well, I'm going to have to do the whole calc if I need to find that. And it's standard method, so we got to work it out, baby. So the next thing we would do logically is the 2 small appliances. They're required. Okay, so it's 1,500 VA each, right? Remember? So it's 1,500 VA times, and there's 2 of them. So that's 3,000. You with me? See that? Look at that. 3,000 right there. I should put my other camera on my page. I got another camera over here, guys, that I don't have on. Hold on. Maybe I can do that. Let me see if that works. I might get lucky. Hold on. All right, hold on here. I might do something here, folks. Hey! Dude, I'm high tech, folks. Don't nobody ever say that Paul ain't high tech, guys. I'm bringing y'all all the stops. Okay? Who else does this stuff for you? All right. So as you can see, 3,000. Here, look at this. Oops. There we go. Figure it out. Okay. So the next one is, it says, well, we have a laundry circuit. Obviously, we see it, we're looking at it and we see a clothes dryer, doesn't mean it's laundry, but we know that generally we're required a certain number of brand circuits in a house. So we got the laundry. So here, how many do we have? We got to have at least 1. So we'll put 1 right here. So that would be 1,500 times 1. So the answer is 1,500. All right. So we got the 1,500 right there. Y'all saw it on the screen. Hold on here. Okay. Oops. Knocking all of my papers around here, folks. All right. So what's next? All right. So the next thing that we're going to do logically is like, okay, now since we have all of the general lighting and small appliance, I get to think about demand factors. It's a standard method, right? So remember in 220.42, it says that I can take the first 3,000 at 100%, and I take the next 117,000 at what? Anybody know? I know you know. Come on. Let's go to the code. Y'all are awful quiet out there. So here's the code. I'm going to go it so y'all can follow it along. We're going to do this together. We're ending on a high note tonight, guys. For all of you that are preparing for an exam, we want to end on a high note. So here it is on the screen, 24.42. Here's what we're talking about. First 3,000, 100%. 3,001 to 120, which typically you'll hear us say the next 117, because 117 plus 3,000 is 120. So it just kind of makes it easier. But we are telling you 3,001 to 120,000, it's 35. And anything over 120,000 is 25%. Okay? So in our scenario, let's come back to me. So in our scenario, we get to take these, and we're going to add lines 1, line 2, and line 3. So let's get our calculator out. So that's 7,500 plus 3,000 plus 1,500. 12,000. So what do we put right here on our little sheet? 12,000. Okay. Now, you carry it down right here, 12,000. Then you take the 3,000 away because we're going to use that later. So the 12 minus 3 is 9. So the 9 goes here. Okay, now you'll see how I'm using the sheet. The 9 goes here. Okay. So then we have no other additional there. So now the 9,000. Okay. So remember what we said? First 3,100. The next value, okay, we get to apply. So when you think about how you run it, if you go back, let's just kind of take you back so you can see in the code. If you look at how you run it, the next one, oops, sorry about that. The next one is 35. Very rarely will you ever make it to this 25. Okay, very rarely will you ever make it to this 25. Okay, so the amount that's over 3,000 all the way up to 120, that's the 9,000. So you take the 9,000, take the 9,000 and put it right here, and then do that times the 35%. Okay, so 9,000 times 35% is 3,150. Okay, so 3,150 goes right here. Now you're going to come down here and you're going to take this 3,000 plus line 7. There was none from line 7. Okay, and there might be something looks wonky in this form, but I'll talk to the author. But if y'all get it, so 3,000, we're going to put 3,000 back into it. So we're going to put the 3,000 from line 8 right here. So this was where the 3,150 goes. Right like that. Trying to make it so y'all can see it. Right there. Okay. Now, you add the 3,000 plus this value back together. And that's going to bring it, so you got the 3,150, then you add the 3,000 back. Okay, remember we took 3,000 100%, we just set it aside, now we got to add it back. So now it's 6,150. Okay, so here's a little tip, folks. This part right here, what we did with the square footage, 3 VA per square foot, the 2 small appliances, the 1 laundry and all that, that is exactly the same in the optional method as well. Now, you don't get to apply the demand factors here, but that's exactly the same concept that you use. Okay, same methodology that you use. Okay, all right, and it talks about that in optional method, which is part 4. All right, so this is the important value. Next, we move on to the appliances. All right, we're done with the general lighting and receptacle load. Remember that 3VA covers the lighting and general use receptacles under 220.14J. You with me? All right, so now let's move to appliances. So what appliances do we have? Well, I see a water heater. So that water heater goes right here, and that's 4,000. I'm just going to write that down because it says 4,000. The next, it says we have a dishwasher, and that is 1.5 kW. So that is synonymous with VA, right? So that's 1,500. Write that down. Remember, try to break it into VA. The next was a disposal, in-sink disposal, and that is 1/3 horsepower. So we did 1/3 already, and we looked that up, remember? And this is the values that we had right here. See that? See that? I can put that under there for you, right there. See the third, 828. So we're going to write that down. So disposal, 828. Okay. And there is no other appliance at that point. That's it. No other appliance. Okay. All right. So what do we want to do? Well, since we only have 3, notice right here on your fast track program, it talks about this 75%. We don't get to use that in 220.53 because we only had 3. So what are we going to do? Just like you thought. We're going to take it. We're going to do the 4,000 plus the 1,500 plus the 828. And that is 6,328. And guess what? We got to take it all. So we're going to write that down right here, 6,328. Okay, so that's another number that we'll need to add at the end. Okay, so I like to circle it. All right, the next thing we do it is the clothes dryer. Okay, so what's the clothes dryer here? Clothes dryer is 4 kW. Well, what did we say earlier? In the standard method, on 220.54, it's got to be 5,000 or the nameplate, whichever is larger. We're not doing the optional, we're doing standard because the question asks for standard, right? So we're going to take 5,000. So that's what we're going to take. We're going to put 5,000 down. Write that down. Next one. Next, cooking appliances. Over 1,750 watts or 1.75 kVA, 1,750 VA up. So in this case, we have 12 kW. Now, remember what we did earlier? We already did this. Since it wasn't over 12, uses column C. It's one range. The demand load for this demand calculation is 8,000. Not hard, right? So we're going to write 8,000 right here. Okay? That's why I like using this form. It just helps you to learn the steps. The next thing is heat versus AC. Okay, so this is where it gets interesting. So I'll get another piece of paper here. So if you look here, we've got two banks of 3 kW, which they gave us the total already as 6 kW, so that counts for two of them. That's electric heat. So then we have an air handler blower motor, which is 1/4 horsepower, which we already looked up the VA, and we already figured the VA, so we're good there. And we have the air conditioner compressor, and that is at 5 horsepower. Oh, we didn't look that one up, did we? So we got to go back because that is going to be utilized, and that is single phase, but it is 5 horsepower. So we're going to treat that. It's obviously it's a motor. It's air conditioning compressor, but it's treated as a motor. Okay, so we're going to do that. So real quickly, we got to go get that VA, and we'll write that down on our sheet. Let's get our little sheet, and we got a 5 horsepower here at 230 volt equals, and let's just go back to the code. Now, there's a reason why, folks, they're not going to give you a whole bunch of these on an exam, because they know that these things takes time to do it, but they will give you any possible piece of this to do each. That's why we use this form in the Fast Tracks program, because typically an exam's not going to ask you to do a whole calculation like this. But if we train you to do it, then you get familiar with it so that if you get asked any little piece of this, then you nail it, okay? So remember, this was a 5 horsepower, so here it is, and it was 230, so that it's 28 amps. So you're going to write that down. So that's 28 amps. So you just need it. So now let's go back to where we were. Okay, we're all the way back. So that's 28 amps. So we got our little list of all of our horsepowers and everything like there, okay? All right, so let's do some math here. So let's look at the heat. So we know the heat is 6 kW. That's a given. Now, a lot of people might look at this and say, so 6 kW is 6,000 VA. And they might look at this and go, well, I can already tell you that I got to get the VA for that 5 horsepower. So I'm going to go 28 times 230, and that is 6,440. So I already know that the AC is going to beat out the heat, right? I already know this, but let's finish it out. So we have 6,440 for the air compressor. The compressor unit. So then we had that. So let's do 6,440. So what was that 6 horsepower again? You remember what the VA was? 506, right? So 506 VA for that. And then we want to add the air handler motor. That was a 4th horsepower. How much was that? That's 667. Added that in there. And anything else? Nope. Air handler, air conditioning compressor, and condenser fan motor. Okay. Now, here's something else as a little tip for you. Okay. A little tip. In that, if the electric heat doesn't say that it's strip heat, then it's probably going to be in the component with the air handler. And the air handler is also going to be utilized to blow that heat. So when you're comparing heat versus AC, the 6,000 for the heat, you want to also add the value for the air handler. Okay, and that is 667. So total for that would be 6,667. Okay, all right. So that would be the heat, because in this case, the air handler also has to blow that heat throughout the unit, because it didn't say they were baseboard or strip heat, right? Like individual, like the one we did for the optional. So we have to add the air handler to that because the air handler is going to, whether heat's going or AC is going, it's going to be blowing this air. So don't forget that, okay? So anyway, that's 6667 is the heat total, and that's the 6 kW for the electric heat plus the air handler. But when we add the air compressor, the air handler, and the condenser fan, we get 6,440 plus 506 VA plus 667 equals 7613. Okay? So, what do you think? What do you think, guys? Anything we need to think about for this application? We had the 2 strip heats. We're doing the AC versus heat. Okay. Now, I also want to take, hold on, 6640. Bear with me here. 25%. I'm going to see if I can skip a step here for y'all and show you a step. Yeah, I'll show you a kind of a step. So typically, one of the other things that we have to do is account for the largest motor. So in this step right here with AC versus heat, one of the things that some of the people do with this is they're saying, I am comparing AC versus heat. In the 2020 code, if the AC is the one that's not the largest, then you have a little bit something that's complicated in 220.60. Not the case here. Okay, so in this case, we're going to say that the value for the air conditioning is going to be the 6. Let's do the 28 times 230 to make sure I'm getting the right. Yep, so 6,440. Then we're going to take the condensing fan, which is the, what is that? The 1/6. So that's 506 plus that air handler. That is a 4th. So that's 667. Okay, so 6440 plus 667 plus 506 is 7,613. So I'm going to write that down right here. 7,613. Okay. All right, so that's my down. Now, the largest motor in this whole scenario is what? It is actually the air compressor unit, right? So that's 6,440. We're going to do that times 25%. So that goes down here in the 14s, 1610. Okay. So we're working each one of them. Now remember, we're taking 25% of the largest motor. And in this case, the air conditioning compressor is the largest motor. It's actually the largest motor in the equation, right? I don't think there's any of them any bigger than that. Now, that is the largest motor. All right, so we got all these values. Now, what are we going to do? We got to add them all up. So let's go on and add them all up. So 6,328. Well, then we got all the ones that we circled, we got to add up. So 6,150 plus 5,000 plus 8,000 plus 7,613 plus 1,610. Okay. We got all the values here. Do I miss something? I feel like I missed something. Maybe I didn't miss. Maybe I didn't. Maybe I missed something. No, I don't think I missed anything. Let me do it again. 6,150. Hopefully y'all are doing it with me. Check my math here. Okay. 6,150 plus 6,328. So that's that one plus 5,000 plus 8,000 plus 7,613 plus 1,610. Okay, so what we should have, if y'all are following along, those that have the fast track should follow along right here. which is right here, number 16. We want to put the total of all these, which is 34,701. Okay. Now, the voltage, obviously, this is a 120, 240. So we'll do 240 volt. So now it's simple, normal, how y'all are used to doing everything. You do 34,701 divided by 240 equals 144.5. And since it's 0.5, and if you remember at the beginning of 220, it tells me that anything 0.5 or greater, I can round. So in this case, I want to put 145. So there you go. There's the 145. All right. So we have 145. And so, okay. So when you see the 145, the next thing you logically think, well, what size overcurrent device do I put on it for the 145? I'm not sizing conductor yet. I'm simply sizing the overcurrent device. Well, if 145 doesn't correspond to a breaker in 240.6, and I don't think it does. So let's go look. I'm glad we did this one this way, slow. So let's go look at 240.6. If a breaker is 145, then we can use it, but I don't think it's don't think there is. So here we're at 240.6, and here we go, folks. Let's see, we got a 125. Oh, got a 150. Okay, so the minimum size service for feeder based on 240.6a is going to be what? 150. Okay. All right, now, best possible answer, folks. Remember now, what size conductor? So we answered the question. So number 13, question 13, what's the answer? What's the minimum size rating of the service? The minimum size. What's the minimum size rating? Oops, hold on. It's going to time me out again. I hate when it does that. So question in our question number 13 should be, what is the minimum ampere rating? Well, the minimum ampere rating is 145, not the device we selected. That's the next, that's the size service. The minimum ampere rating is 145. So that's question 13. So we can answer question 13 is it, and we'll just do that over here. This is question number 13. All right, so number 14 says, what's the minimum size service? Well, remember the service is, I'll do that in a minute, June. The service goes over is what the rating actually is of the breaker, okay? Hold on, we're not there, Moses. You're getting a step ahead of me. We're sizing the service now. Remember, the 83% rule is for the conductors. That's for the conductors. We have to get the service rating first before we can even use the 83, but I like what you're thinking. I like how the brain is working. All right, so the service is 150, okay? The minimum ampere rating is 145. Because it didn't correspond, that's how we ended up with the 150. So we're using the 150 to do exactly what Moses is saying and saying, hey, wait a minute. Can I size it to 150? Absolutely. But can I use the rule in 310.12, or if you're in the 2017 code, 310.15b7, can I use that rule? The answer is sure. Why not? So let's do it. So in this case, since the service rating is 150, let's do it. So 150 times 83% is 124.5. No conditions or uses have been spoken about yet. Nothing, it's service, so nobody does usually anyway. So I need a conductor that's good for at least 124.5 amperes. So let's go to the NEC. And we're using the rule, assuming it applies, and it does in this case. And we're going to go, I like how you're thinking, Moses. Let's go to 310.16 and find a conductor. And again, since we're not doing any adjustment or corrections, we're going to go straight to what we're dealing with. And since it's 124 amps is what we're looking for, remember the rules in back for 110.14c1. When it's over 100 amps, you're going to be under 75, so that should be a given to you by now. Even if it didn't give it to you in the question, it should be a given that you understand 110.14c rules. So here, we're going to go down and find a conductor that's good for 124.5. And right here, it looks like it'd be a 1 gauge. So the answer, and let's go back now to the browser. So the answer to, oh, and it did give us a size. There you go. It says consider the minimum size THWN. So that tells us it's under 75 as well. So even if we didn't know the rules in 110.14c, it doesn't really matter because THWN only has one H, so that's 75 degree rated column. Again, we only use 90 for adjustment and corrections anyway, so it really wouldn't matter. There's no adjustment and corrections that have been given in this equation. So we know that we'd be under the 75 degree column as well because it is THWN, and that's what's under the 75 degree column. Now, if it had a -2, it could be 90 or 75, but it would be 90 wet or dry. But in our question, it just said THWN. So it's just 75 degree. So 2 ways to get there. You could have known 110.14c, or you know that THWN is rated 75 degree rating. Easy peasy. So then you go down and say it's number 1. So number 15, and I know I'm in the way, but you get the point. It is going to be 1 gauge. So that answers this question right here, number right here. Right here. So that's 1 AWG. All right. And then last question here, 16, it says, what's the minimum size grounding electroconductor? Well, guess what? It didn't say it was ground rods. Here's another thing that people screw up on exam. It didn't say ground rods. It didn't say plate. It didn't say pipe. It didn't say U for ground. It didn't say, anything like that. In 250.66 A, B, and C, if they tell you it's a ground rod, if they tell you it's a concrete encased electrode, things like that, then you can use 250.66 A, B, and C. If they don't tell you what type of electrode's being used, then you want to go to the table, 250.66 table, based on the size of this ungrounded conductor. In our case, it's a 1, so we're going to go to the NEC. And we will go back and we will go to 250.66, which you should know by now, is when you're sizing grounding electrode conductors. And we'll go to 250.66. I will eventually get there, I promise. There we go. 250.66. And since we are as a 1, the size would be a 6 copper. Okay? So 6 copper. So let's go back to our question. So what's the minimum size a grounding electroconductor? And you're thinking to yourself, why isn't it aluminum? Remember, on an exam, always assume copper unless they state otherwise. Okay? So in this case, the answer here is 6 Cu. And that's how you solve 13, 14, 15, and 16. And now the other ones, we don't have time tonight because again, my wife is going to kill me, is exactly the same way. You just use the optional method. It's no different. In the optional method, you simply take in all the nameplates. The beginning starts out the same, and maybe I'll save that for another episode, and we'll do that. But again, I wanted to give you the basics. So let me figure out how to turn this camera off of here. There we go. Let me get back to the main menu. Great episode tonight, guys. We spent, what is that? A little over, what did we start at? 7, 8, 9? A little over 2 hours. We covered a lot. That is, believe it or not, Unit 8 is one of the tougher units. 11 is tough as well. 13 is tough as nail. But inside the Fast Tracks program, you learn how to do all these. But I think what's important is that you get to use, this form is awesome. I mean, look at it. I worked this whole one out using this. Now, some people say, yeah, but I don't get to use this on an exam. Absolutely not. Okay? But what it does is train you. Now, June, let me go back to your equation. Let me go back to your question because you asked where I got it because I want to make sure I cover. I want people to not think I forget them. God, I look like a bum. Anyway, I want to make sure that everybody knows where I got the values at, June. where I got that 7,613 you were asking. Okay. So let me go back real quick to that, because I just remembered that I did not answer that for you. And I want to make sure you're clear. I want you to be successful. And to be successful, I have to be very accurate. I take a lot of pride in making sure I make things clear. Okay, so June, what we did was we compared the heat versus AC. The heat is 6,000 kW, plus the air handler, because you know it's going to be blowing that heat around, okay? And so the air handler, remember how we got those values? The air handler is valued at 667 VA. So this is 6,667 VA for the heat and the blower. That's the heat equation. You put that to the side. You got to go to the largest versus heat versus AC. 220.60 in the code. Put that to the side. Now, where did I get the 7,613? It is 5 horsepower motor at 230 volts. You're going to 430.248. And that tells you that it's 28 amps of FLC. Once you get the amps, you got to convert it to VA. So I go 28 times 230. Always use the voltage that's in your question. Okay? Equals 6,440. Then I add the VA of the other two, the air handler and the condenser fan motor, because they will be going at the same time that the air conditioning compressor could be going, right? So remember, the blower motor was 667, so I'm adding that back to it. And then also remember that 6 horsepower condensing fan, that was 506 VA. Okay, so I'm adding that to it. And that's how we got the 7,613. That is larger than the 6,400, no, the 6,667 for the heat. So you take the larger. In this case, the AC wins. And that's what you put down here. And then the last one is you take the largest motor of the whole dwelling. Okay? And in this case, that air conditioning compressor was the largest motor, but I only need to capture that additional 25%. So you take that 6,440 times 25%, and that's where I got the 1,610, and that's what you write down as that extra 25%. Okay? You're saying, where does that say that in the code? Go look at 220.50. That talks about the motors and the air conditioning unit under 440 that has to be taken at 125%. Well, you're already taking it at 100%. So all the reason you're capturing that additional 25% is to meet that rule. I need that additional 25 to meet the rule that says I take it at 125%. Well, I already took it at 100%. So all I need to capture is that additional 25. And that's why we go through that. Okay? All right. But that's where we get those values there. Hopefully that helped you out. If not, go back and watch the video again. I'm sure it'll be, okay, working and working out. Well, look who creeped in here. Wow. Look who reared their head at the very end. Jay Grundberg, who poked in here at the end. Hey, Joseph, welcome to the chat. You're a new member. Thank you. Coming in. So again, make sure you really understand that in your 2017, that is 31015B7. That's that 83%. And if you're in the 2020, again, then it's 310.12. But remember, that is purely without any adjustment of corrections. If you do have adjustment of corrections, then forget that table. Just use the 83%. And then go watch my D-Rating Demystified, because I show you how to do it. Okay? And we'll do that for another night, maybe next week. All right. That's a lot of stuff. We covered a lot tonight. How much do you think you'd pay for that one-on-one tutoring? All right. I gave you 2 hours of my time for free, because why? Because I'm going to sound like I'm in the presidential debate, because I believe in you. And I do believe in you. And you can be successful. Code is easy. Don't make it hard. Make it easy. Okay? I like to do the math. I don't like to use those little tables. I like to learn the percentages, and I just am that way. I'm anal about it that way. Anyway, great show tonight. Great. Jay knows me well. All right, so I want to thank you all again. Appreciate it. If you feel inclined to donate, you appreciate it, you can donate using the little money symbol at the chat box. Appreciate anything you donate. It helps. If you're interested in getting any of our lights, boy, don't you wish you could take 2020 and go like this? Just like Men in Black, and turn it over again, or at least get rid of 2020. Don't you wish you could just make it go away? Anyway, our little screwdrivers, you make a donation on our website, you get these, or you donate tonight, and then send me your email, your physical address. And if you win the drawing, then I'll send you. Anyway, there you go. We appreciate y'all. Till next time, folks. Unless anybody's got any questions. Anybody got any questions? I'll wrap this thing up at 9:30. Anybody got any questions on anything that we went over tonight? These forms, again, are amazing. You just got to see how I use them. Print these things off if you're in the Fast Tracks program. If you're not, just get used to doing the different steps. But these things are really nice to practice. And what it does is it teaches you every little step so that as you get good, you'll realize, okay, standard method, 3 VA per square foot. 2 small appliance brand circuits minimum. If you have more, you got to count for more, but 2 minimum. 1 laundry circuit. Apply the demand factors, 220.42. Boom, 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 boom. Fine. Put that value down. Now, that's the general lighting and small appliance. Next, move on to what? Appliances. If I got 4 or more, I can do a 75% demand factor. If it's less than that, 3 or less, then I got to take it at full value. Boom, boom, boom. Work your way through it. Okay? And then on next week, maybe we'll go over similar. We'll do the optional method. I'll answer a few more questions. And then what we'll do is we'll size neutrals. So I'll teach you how to size neutrals next week. Because again, I can't talk all night, guys. My wife will divorce me. Okay? So that'll get you excited. Come back next week. Share it with your friends. Go on all your social medias. Tell them, hey, man, I had a great time over there on that forum. That was awesome. Okay? Well, I got to show y'all something. I don't know how well this will come up on the screen, but I got to show y'all something that's totally wicked. Y'all know this background with Tesla and everything? I got a smoker. I like to smoke, smoke meat, things like that. Check this out. I don't know if you can see it. Look at that. I've got it actually, that background on my smoker. Isn't that the coolest thing? I just did a Boston butt this weekend. Oh, it was awesome. Tasty. That's why I'm fat, but it's tasty. All right. Hey, I appreciate all of you. I really do hope you learn. I hope I've been beneficial to you, that you gained something, you learned something. I think if you learned anything, you know that I'm here to help. And despite what you might read out there on the fake news, I do try to help as many people as I can. Okay? So that's it for tonight. We'll call it a night, and I appreciate all of you. And if you got any questions, remember, come back next week. We are going to do next Wednesday. I should be fine. Me and Jay got Electrician Live this weekend, so make sure you check us out at 8 p.m. Central Standard Time, right here, same bat channel. Okay? What did Paul's? How did what did WWC is? How did you get all those knowledgeable, Paul? Please tell me. Oh, how did I get all this knowledge? Ask my wife, because she's the one that sacrificed for 30 years of me teaching code, being embedded in this code book all the time, sitting on code panels for many years. When I was 15 years old, I decided electricity was my thing, and it served me well my entire life. I'm very blessed with electricity. I'm very thankful. I like to think that I owe that gentleman an awful lot, because he inspired me when I was very young. And I enjoy it. I enjoy helping you folks too. Okay? So, that's it. Jay said, dude, I learned this because I watched YouTube videos. Absolutely. Daggone right. I'm a YouTube junkie. All right, folks. Appreciate y'all. Till next time, stay safe. God bless. And I appreciate you all. And be safe out there till we catch you next time. Later.